Matriculants, siyanamkela kwakhona. Ngumr Mnyaka lo sembogweni. Sifikile kwakhona madoda, sizoncedisana nawe. But today we'll be focusing more, emphasizing the principles to a rate of reaction. Take note of this. The topic is very short, and the marks prior is close to 20. But there is something interesting about the topic. It's a continuation from the rate of reaction, as and basis. So the language is the same. So that is what I want to lay down for you. In terms of theta upper, there's another question paper. So please make sure you listen and understand what we'll be saying to you. Yes. So this is Food and Health program. Welcome all the grade 12s. And make sure paya ungane phakathi YouTube wethu kaloku subscribe siyafumana kule number ke ukuze uncedakale for wena ukuze ukwazi ukusicontact. This is 073 9518 176. Uzasifumana apho WhatsApp number wethu. Also na ku Facebook Funda Nathi program sikhona pha uncedisana nawe. So please pay more attention to what you'll be doing, because the result is upper into the exam. You see? So please make sure you listen carefully. Okay. Asiya kuyo madoda. Nanti option B. Apha sithetha nge-rate of reaction. Yintoni i-rate of chemical reaction? Umisi wakho already zayixelele phaa esikolweni. Uyayazi rate of chemical reaction. So upper, this is a change in concentration of products or reactants per unit time. I know you know already a definition your reaction rate. So this is what we have here. Le reaction rate kwenzekani kuyo? Apho into enzekayo ku reactor into ezimbini. Sifumane i-product. Le product usually yiyo esi-analyzer, because the product izosoloko ifumaneka, but le product ke ngoku iphuma njani lento liyifunayo. In this topic, please make sure siyacela apha uzazi i-effect the rate of reaction. Into zokuba when you increase the temperature, the average velocity will increase, that will increase kinetic energy, and that affects the number of effective collision, that increase the rate of reaction. I believe you already know those things. Increase in concentration, increase in number of particles, then there will be more chances for effective collision, then reaction rate increase. You must know those things already. They are there in your textbook. So please make sure you know those things, because here we are applying them. We are not doing them. We are applying those things. So please make sure you know, but if the surface area is greater, then you'll have effective collision high. If the surface area is small, then it's about lower rate of reaction. So then that's all strong as. I'm not here for 8 definitions, but so the 7 as the rules, there's a principle. So I expect every matriculant to know those things. They are very important, and the corner textbook yakho. So apha into enzekayo apha xa ngabe senzeka le reaction yethu sithetha ngayo yenzeka apha le reaction. Le reaction yenzeka kwizinto ekuthiwa zi-apparatus. Ezi apparatus unazo phaa kwitextbook yakho, uzazifunda phaa. Apho uthetha khona ngo-conical flask, uthetha khona ngo-stopwatch, uthetha khona nge-independent variables. Ininzi ethetha ngayo phaya, you see. So into endifuna siyijonge apha yinto yokuba njengoba le reaction rate, ezi reactions zisenzeka kule apparatus, kwenzeka ntoni? Ezi reactants zokele conical flask zireacte, zabe zireactile zisinike i-product. Let us look at this product. Nje le product yakho ayonto ingako, zii-reactions ziyi-2 eziphuma phaa zi-product. I believe you know already. Zinto ezinto esithetha ngazo. Wena une-reactants, une-products zakho, Okay, masisebenzele ne-reactants une-products ono-EA. Ifuna ukwazi ukuyilebelisha ke le nto ne. This is activation energy. Make sure uyakwazi ukuyilebelisha le nto. Zimakisi zakho ezi. Still, this EA is the same as this one. This is the energy of reactants. This is 0 point. We use this one as 0. Then this energy, this one, is the energy of product formation. This is EP formation. This is the energy of product formation. In the energy siyidingayo ukuze siformishe products. Then this energy lapha ezantsi ile energy yantoni ye products is this one. Then this total, the energy reactants ipha phezulu plus activation energy zombini zisinika lento kuthiwa activated complex. That is where new bonds are formed and old bonds break. So ufuna ukwazi ukuyilebelisha lento according to this diagram. Note this product MEP siyibiza apha ngo-change in H. Ncwadi yakho izothi enthalpy. This is the product energy of what? Of product. This energy iyareleaswa ku-exothermic reaction and kondaba already yayazi by now. Igcinwe kwi-endothermic reaction. So endothermic reaction iyayi-absorba le energy, then exothermic iyayikhupha le energy. This is what we will be focusing, because apha une-reactants ezireactayo, then as reactants they need the energy. A must be more than activation energy, because this is EA. Ukuze zofika activated complex. Then at this point the activated complex, that is where now i-reaction isenzeka khona. Then xa isenzeka le reaction siformisha ii-products zakho ube ne-products. Now this is what we will check. Now kwenzeka ntoni xa kusenzeka i-reaction, ziformisha kanjani ii-products? So yiyona nto sofocusa kuyo le. Please make sure you understand what we are saying. Okay, now let's go on now to where? To the reactants and i-products. Into efuna ukuyazi apha, uzonikwa apha ii-techniques eziyi-3 ze-reaction ezawuphuma kwela phepha lakho. It's either unikwa i-metal plus acid. They usually use hydrochloric acid. We know here that we'll have salts plus water plus hydrogen. Sorry, not water. So this is gas released. They can also use calcium carbonate. This calcium carbonate reacts with nala acid chloride. Then ziphuma nantoni apha? Na calcium chloride. Calcium chloride plus carbon dioxide plus toni plus water. See, the reaction is of nazo is sometimes they may take inactive sodium thiosulfate. You see, they may take sodium thiosulfate. Hey, yena manipala kahle na. So sayibona apha product. Then apha siphuma apha the sodium chloride. This must be Na2. Siphuma the sodium chloride, which is salt, plus SO2 plus iwater over corner plus sulfur. The product zakho ezi surely zikhona ku-textbook yakho. These reactions zoyi-3 ekufuneka sizi-understandile. These reactants, these 3 reactants zezi zilapha kule reaction. So xa zireacta eza reactants already zine-concentration yazo ngaphakathi. Already zine-amount of concentration of reactants zibe kwi-mass for a solid, because usually metal by solid, this one and also this one, iba aqueous zombini, then hydrochloric acid. You see, so ezi zine-solid sijonga surface area yazo but zayiveza lona. So these reactants ezi zireactayo zisinike ntoni? I-product. So this is the case now. You see, now kwenzeka ntoni kwezi reactants? Lapho ndifuna ufocusa khona. I want us to focus more on this reactions esinazo. We already saw i-product yethu uba i-endothermic okanye exothermic reaction. That we don't have a problem with. We don't have a problem with that. We already know, you see. So we already know about endothermic and exothermic reaction. And let's take for example Mg. So let's see apa apply kwezinye ke eza reactants. The common one. MgCl2 plus bond plus hydrogen. When we look at this, kula reaction xa isenzeka kukho apha izinto ekuthiwa yi-excess and limiting reactant. I-excess and limiting reactant is one of the what? Is one of the reactants. Kwezi reactants unazo zimbini, enye funeka uyazile uba yi-limiting reactant, enye ibe yintoni? Ibe yi-excess. Zizinto ezifuna uzazile. This they will tell you question paper. If abaxelelanga, note these terms. They will say one of these react completely. That's why you want a question paper yakho le. So if magnesium react completely, that means you excess hydrochloric acid. If hydrochloric acid react completely, that means you excess in magnesium. So zombie izinto limiting reactant. Okay, le complete reaction. Limiting reactant. The limiting reactant is not the same way. It's not determining H weight, which is output yapa, which is gas liberated. A complex equations must be balance. Let's show you balance the equations is. This balance you understand the part. Make sure you balance is. So we go to pa la kapambi. So much on apa kule case unayo. Let's say magnesium is limiting reactant. The limiting reactant, hey, let's say magnesium is limiting reactant. Limiting R or Mg. So if magnesium yetu is limiting reactant, it lendo is a producer is a producer H. The hydrogen gas is a producer moles magnesium. A magnesium is a reactor yonke isinike H2. And this limiting reactant must be constant. If upon a reaction as E2 ezenzekayo experiment ezimbini. So ithi lento this magnesium must be constant because kaloku kwenza i-fair test pha. Kodwa question paper yakho udibana lethiwa why is this reaction? Why is the comparison so fair? You see. So that means the amount of the limiting reactant in both experiments must be the same. Then the product yakho pha ibe ngubani? Ibe hydrogen okanye carbon dioxide okanye oxygen, and ibhalanga reaction oxygen up where kwenzeka khona decomposition. So this is the case S9. So apha limiting reactant le equation is nika product kabani hydrogen, then excess yona ihlala njalo. Note the language zodibana nayo even ku KC, even ku acids and bases, la language excess and limiting reactant. Make sure we understand that perfectly. So apha njengoba ngoku unale limiting reactant kukho factors as affecta i-reaction rate. Zezinto besithe funeka uzazile. These factors affect i-reaction rate as factors the concentration, the surface area and the temperature. Those are the three factors, not the volume. If volume is not part of it. As factors they affect only a reaction rate. They don't affect the heat of the reaction. That means they don't have anything to do with the product. The product yakho yapha eyifumana pha ayizo affect a concentration itshintshe because a concentration increase okanye i-decrease. Nakanjalo if you increase surface area okanye i-decrease okanye temperature, that product will always be the same. Into the affected factors, here reaction rate, time taken for the product to take place. So these factors, these factors as affect a reaction rate. So in 3, you must know this. This is explained by Kalin. Njengoba ezi factors affect reaction rate, this factor litshintshayo because now funeka sikwazile pha u-identifya i-dependent variables. I-dependent variables zisuka kwezi factors zethu, zisuka apha i-dependent ne-independent variable. I-dependent variable xa usikesha igraph, i-hydrogen le iprodyuswayo, this is hydrogen gas. Idepende phi hydrogen gas? Idepende kwi-limiting reactant le isinika ntoni? I-product e-hydrogen according to our example. So in this example, i-dependent variable phaya ngubani? I-hydrogen. I-independent variable izoba yintoni ke ngoku? Siyazi apha if i-concentration iya-increase, then the-reaction rate will be high. So that means we need a number of experiments as different. As experiments zingayi-2, zingayi-3. If sijonge concentration kwezi experiments on that, let's say experiment 1, 2, 3 aba sinabo pha. Kise nje. Okay, must be 1 and 2, ne? Must be 1 and 2. 1 and 2. Then sibe ne concentration up. Sibe ne mass pha. Sibe ne temperature. Sorry man. South Africa wethu lo, which is surface area yakho. Since nazo is if the strong concentration, this concentration is about different upper. That means the independent variable kule reaction le itshintshayo. That is how we determine independent variable. Independent variable will be one of these factors. SO3. Please note that will be one of these factors. Le itshintshayo kwezi reactions zakho, kwezi experiments zenzayo. The independent variable. Then the surface area yona, let's say surface area yako is about 0.2, 0.2. The temperature is 28 degrees. 28 degrees. Where's reactants? Where's experiments? Itilendo independent variable concentration as bar sifuna ujonge effect pa. Yoba if you increase the concentration, how will be the surface area? Then the surface area and temperature. These are controlled variables, these ones, because they must be constant if one changes. Then if as change, if there are changes on that, we already know if there are changes, the rate of reaction will increase. But there is no need to changes on bini because up the strong factor A1. So in principle up, if collecting one must change and the other two must remain constant. So sometimes when you table yakopa or you the table, look at one that changes, then that one will be your independent variable. Yes, so this is the case as now apa with the variables zethu. So please make sure uyakwazi ukuyehlulela reaction yakho uba xa ngabe iqala reaction isenzeka pha kwenzekani.